Okay, Trig students, we're going to go over or continue into 14.1 into the rest of that. Talk about the difference of vectors. If we're talking about a vector u and v, and we're taking u and we are subtracting v from it, that's defined to be the vector u plus negative v. Remember that's same as subtraction. Subtraction is adding a negative, where negative v is the product, of v and negative 1. Negative values indicate the opposite direction. Okay, so it's of the same magnitude as v would have been, however it is going in the opposite direction. Now when we're talking about the bearing of a vector, that is going to be the angle measured clockwise. Okay, so that's a little bit of a switch. We're used to measuring counterclockwise when we're talking about a positive angle. When we talk about the bearing, a couple things are different. We now measure clockwise for our bearing, and we measure from due north around the vector. Okay, so bearing of vector v is the angle measured clockwise from due north around to our vector here. So if we're talking about a 30-degree bearing and 100 kilometer magnitude, we're talking about this vector right here. This would be our coordinate plane. Due north is up, as you recall, on a piece of paper. So if we are talking about a 30-degree bearing for 100 kilometers, then let's get a arrow here. Go ahead and make that in blue. 30 degrees is probably about right there. Here's our vector, and we would say that that is 100 kilometers, right? Okay. Now a 210 degree bearing with a 70-mile magnitude would be this. Well, all the way down to south would be 180 degrees, and I need to go another 30, so we'll call it about right in there. Would be about 210 degrees, and that would be a magnitude of 70 miles. Okay, so that gives you an idea of how we're measuring here. Remember, we measured that. That was our 30 degrees. This is our 210 degrees. We measure that from due north. So we'll be dealing with these directions as we continue through here. We're going to go right into a couple of examples, and we're going to use our trig that we've learned so far in order to solve these. So first things first, you need to kind of look ahead here as we go through these. So find the magnitude of the resultant vector w and its bearing. Okay? So if we have a vector u with magnitude 140 miles and a bearing of 70. So here's where you start. We're going to start right here on this coordinate plane. Okay? And a bearing of 70, remember from due north, is going to be in that direction right there. And I've already drawn this in, so I've got that right there, right? So that is vector u. We're going to label that. And if we add vector v to that, vector v with a bearing of 330, I have to start where I finished, and at due north was here. Then if I was going to go 330 degrees from there, I go all the way around. Here would be 90, 180, 270, up another 60 degrees. We'll call it about right there. Call it there. Okay. So we're going to have to start piecing things together here, but we'll take care of that here in just a second. So that was V, and this is 80 miles. This down here was 140 miles, right? 140 miles. So let's start piecing things together. We know that our resultant vector is going to be this one. We're going to make it green. We start over here where we originally started and end up where we ended there. So we're going to call that vector W. That's what we have here, the resultant vector W. And now is when we start piecing things together. So let's think about what we've got here. Think about when we went down to the blue one. The blue one was a bearing of 70, which made this little sliver right here. Whoops. Let's fill in the blanks with black. That little sliver right there is 20, right? Which makes this little sliver in here 20. As you can tell, I'm going to try to piece together the angles of this particular triangle here that is formed. Because this is what I want to know. Okay, I'm going to need to find that out. Because when it says it wants the magnitude and the bearing of this green line, I actually want this right here. But in order to find that, I'm going to have to get this value. Okay, so let's see here. Start piecing this together. So if that was, let's see, if that was, I know what this is up here too, right? I went around to 270 and then all the way to 330. So that would be another 60, which would make this whole thing 80 degrees, right? 80 degrees right here in this angle. I know this is 140 and this is 80. Now, what you're going to have to do here is think back to your trig formulas. When I have a side, an angle, and a side, I should be able to figure out what W is. And that is my law of cosines. If you remember, my law of cosines will say that W squared, I'm going to make this green here. Let's say that W squared is going to equal side squared, 140 squared, plus the other side squared, 80 squared, minus 2 times the side times the other side times the cosine of the included angle, which I know is 80 degrees. Okay, so W is going to be the square root of that, right? I'll take the, and I recommend just typing that all into your calculator. So W equals, go ahead and try that in your calculator real quick. Hit pause and try that. You should get 148.7. And that would be miles, right? Miles. So, that would be our magnitude of W. Magnitude of W is 148.7. Now I need to find its bearing, which is going to be right in here, right? That's my bearing. It's going to go in there. But before I can find that, I'm going to need to find this alpha in here. That's my unknown. Well, remember, if I have this, if I have a couple pair of things, I can find that. So now that I have this angle and this side, I can use the law of sines. Okay, so remember, always put your unknown on the top when you're dealing with the law of sines. So I'll have the sine of alpha over its opposite side, which would be 80. And that's equal to the sine of 80 over W, which I now know is 148.7. Okay, so here is what I would do. I want to multiply 80 over here, right? So the sine of alpha is equal to 80 times sine of 80 degrees over 148.7. Now you want to make sure that you're back in degree mode here because we're not using radians. So as you type this into your calculator, remember I'm looking for alpha, which means I need to use the inverse sign in my calculator. Sine 80 over 148.7. If you type that in exactly how it's seen in your calculator, that alpha is going to be 32 degrees. Now, if that alpha is 32, then I can figure out what this bearing is, because the bearing is going to be, if I know this is 20 and I know this is 32, I know this whole thing right here is 90 degrees, right? So the bearing would end up being 90 minus the 20 minus the 32. So the bearing of this resultant vector is 38 degrees. Okay. So using a couple quick rules of trigonometry here, law of cosines and law of sines, I figure out that my resultant vector here has a magnitude of 148.7 and a bearing of 38 degrees. Alright, I'll do another example here. We'll wrap up. Airspeed of a plane is 180 kilometers per hour and its heading is 130 degrees. The wind is blowing at 40 kilometers an hour from 50 degrees. Find the plane's ground speed and bearing of its true course. Alright. So here's what we're going to do. It's got a heading of 130. So the first thing we're going to do, bearing of 130, I would say, somewhere in that vicinity, right? Filling in the blanks here, I know this is 90. That's going to be another 40 degrees in there, okay? Just kind of piece things together. I would, let's see. Make a little coordinate plane here where it stopped. So, okay. So then it tells me that the wind is blowing from 50. Okay? So if it's from 50, that means a bearing of 50 degrees would be out in here, right? Well, what that's telling me, though, is it is blowing from that direction. So let me go back, get an arrow, make it red. If it's blowing from 50 degrees, it's going to be coming this way, right? And that was 40 kilometers per hour. So try and be, try and keep it to scale as much as you can. This up here was 180 kilometers per hour. And this over here is 40 kilometers per hour. Okay, and we can measure that in that magnitude in kilometers per hour just as easily as we can in a distance. Okay, so we are looking for the plane's ground speed. So essentially, if the plane starts out heading here and that wind forces it to end up here, that means that its ground, its path from a straight ground path would be this. Would start there and ends there. That's what its path would look like from the ground. Let me do that a little bit better. Whoops. Bear with me here. Alright, there we go. Now we look good. And this is our ground speed, we're going to call it. Okay, so ground speed. So again, we'll need to kind of try to piece some things together here. Because I'm going to want to know the bearing of that. Well, this is 90 degrees up here and 40, and then so I'm going to need to try and find that value in there. And you can name that X or Y or whatever you want to name it. I'm just using alpha. So first things first, I'm going to go ahead and try to find the ground speed, because if this was the air speed against the wind speed, this would let me know what my ground speed is. And it should be less than the airspeed because, as you can tell, this wind was hurting. You know, it's kind of blowing against the direction I was heading. So, anyway, plugging it into the equation, g squared is going to equal 180 squared plus 40 squared minus 2 times 180 times 40. One thing I did forget to show you is I have to figure out what this angle is, right? So if that's 40, then so is this. Hopefully you remember why, because these lines are parallel and those would be alternate interior angles. Okay? Now I know that this was 50 over here, which made that 40, and vertical angles would make this 40 and this 50. I didn't need to know that 50, but see, remember vertical angles, these angles that are across when two lines intersect, the angles that are across from one another, which makes this whole thing 80 degrees. Alright? Kind of forgot that up here, didn't I? Got ahead of myself. So that's going to equal the cosine of, or not equal, but cosine of 80 is going to be in my equation. Okay, so I would go and take the square root of both sides and get that g is equal to 177.5 kilometers per hour, and that would be my ground speed. I'm sorry, my ground speed, which is equivalent to the magnitude, right? That's essentially my magnitude of that. So now I need to find my alpha. So I go and use the law of sines to find my alpha. Sine of alpha over the opposite angle. Whoops, the opposite side, I'm sorry, which is 40. About messed up. And that's equal to the sine of 80 over my unknown side. Okay, which I know now, right? So the sine of 80 at 88 over my unknown side, which I now know to be 177.5. So sine of alpha equals 40 times sine of 80 over 177.5. Understand that you have to do the inverse because I'm looking for this angle, so sine inverse of 40 times sine 80 over 177.5. All you have to do there is hit enter, and you get alpha being equal to 12.8 degrees, so that's 12.8 degrees. Figuring out the bearing, then the bearing would be 90 plus 40, or 130. Remember, the bearing of that blue path was 130. So 130 plus the new alpha, because that would be my total bearing of that green line, right? Which is 12.8. So the bearing of my ground distance would be 142, or my ground path, sorry, 0.8 degrees. Okay, so there's my bearing. Here was my ground speed up here. The assignment we're going to work on, page 664, written exercises, we're going to do 5, 7, 8, 15, and 17. We're also going to work on problems 1, 2, 5, and 7. All right, have a good night.